Dear students, in this video, we are going to look at discontinuous variation. So, this is one of the forms of genetic variation. Now, there are characters which vary between members of a species, and those characters vary discontinuously. So, in other words, there is always clear-cut expression between the characters varying within the members of the species, what we call discontinuous variation. Okay? Characters, or we say variation, whereby individuals or organisms of a species, whereby individuals or organisms of a species show clear-cut division or expression, of the character between the organisms, whereby individuals or organisms of a species show clear-cut division or expression of the character. That is what we call discontinuous variation. It is where there is clear-cut division of the character varying between individuals of a species. Or I may say that it is where there is clear-cut expression or clear-cut division of the character varying within individuals of a species. So, that is discontinuous variation. It's where there is clear-cut division of the character varying within individuals of a species. Or it is variation whereby individuals or organisms of a species show clear-cut division or expression of the character. So, that is what we call discontinuous variation. So here we can write that examples of characters that vary discontinuously. Include. So, examples of characters that vary discontinuously include: one is sex, such that one is either male or female. That is one of them. Then two, we have blood groups, whereby we have four: blood group A, blood group B, blood group AB, and then blood group O. So there is no any other blood group other than those four, and so an individual will possess any of those four blood groups, and so we say it is a character which vary discontinuously. The other ones, we have tongue rolling, so we can record them here. So one is called sex, whereby an organism is either male or female. An organism is either male or female. The other one is tongue rolling. So one can either be a tongue roller or a non-tongue roller, and tongue rollers are very few within the population. So the other character is blood groups. Blood groups. That is blood group A, we have B, then AB and O. AB and O. So an individual has any of the four blood groups mentioned here. Then the other character is eye color in Drosophila. Eye color in Drosophila. Eye color in Drosophila melanogaster, or the fruit line, whereby some of the fruit flies have, of course, red eyes. Some of them have red eyes, whereas others have white eyes. Others have red eyes, then others have white eyes. The other example here is hemophilia. It is also an example of discontinuous variation. Hemophilia. The other one is albinism. One can be an albino. Okay? Albinism is also an example of a character which varies discontinuously. So previously we discussed what we call hemophilia and then albinism. So I believe that one is not a challenge now. You've known what they mean. Now, for characters that vary discontinuously, when you plot the number of individuals against the character, what happens is that a normal distribution curve is not obtained as in continuous variation. Instead, the graph can best be represented by a bar graph as shown on the board. So, say for characters, or for a character that vary discontinuously, when it is plotted, when we say when the number of individuals, 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 when number of individuals is plotted against the character, what happens is that a normal distribution curve, is not obtained, and can best be represented by a bar graph, as shown below, as shown below. So what happens here? For a character varying discontinuously, it can best be represented using a bar graph as shown on the board. So now when I draw my vertical axis or y-axis and then horizontal axis like that, what happens is that, suppose I have number of individuals, I have a number of individuals against extent of character, e.g. 6. So want to show it clearly. If I have character e.g. 6, then I will have, for example, a bar. I can have a bar representing male. Okay, these ones can be, let's say, female, and then we can have another one like this, where we can have male. So it depends on which number is greater than the other. So if we have male, then the other individuals will be female, like that. So this one shows that the character is discontinuous. There is a limit, okay? There is a limit. So we have male, these are male individuals within the population, like in human beings. Then these are females. So my graph shows that the females are many than the males. In another case, the males can be many than the females. So now, that is what happens. Then finally, characteristics of characters. Characteristics of characters that vary discontinuously. characteristics of characters that vary discontinuously. So what are they? One, controlled by one gene. Controlled by one gene. Two is that not measurable. Not measurable. Thus, they are qualitative. They are qualitative. They are qualitative. So, if they are not measurable, then it means that they are qualitative. Secondly, they are either present or not present within individuals of a population. Okay? Either present can either be present, or absent, can either be present or absent in a population or in a species. So, members, those are characteristics of organisms that vary continuously, controlled by one gene in most of the cases. Then two are not measurable, so we say they are qualitative. And then three can either be present or absent in a species. So, members, let us meet another time